Now we're going to talk about a very overloaded topic over here, the present and the future of MySQL HeatWave. So just to recap, MySQL HeatWave is a fully managed data service from Oracle. It is offered in multiple clouds, OCI obviously, but Amazon as well as Azure. HeatWave has been designed in a massively scaled out manner such that it can process data which is in the object store. And when I say process data, it means if you want to run analytics, if you want to run machine learning, if you want to run transaction processing, all of these capabilities can be done when your data is in the object store. And not only can it be done, it can be done very efficiently. If you have data which is transactional in nature and you want to store it in a database, people typically store it in the MySQL database or very often store it in the MySQL database. HeatWave can also process data coming from the MySQL database. Right? So HeatWave can process data from the object store. HeatWave can process data from the MySQL database. But what is interesting is in a single query, you can have data, part of the data coming from the object store and part of the data coming from MySQL. And hence the term lakehouse, right? A combination of data lake and data warehouse. There are two other things I want to point out about this diagram. One is that when customers have their data stored in a MySQL database, they're going to adhere to the MySQL syntax, MySQL semantics, and there are millions of applications out there which have been designed or which work with MySQL. But when you have your data in the object store, the question is what syntax or what semantics to use. And in the past, people would extend their or come up with proprietary language to query data from the object store. With MySQL HeatWave, you can take existing applications which run on MySQL and have them run against data in the object store. This data can be structured in nature, semi-structured in nature, and very shortly unstructured in nature as well. Right? So that's the first aspect, that no proprietary extensions. This is adhering to the MySQL syntax and semantics. The second thing to point out about this figure is that many of our customers, not just our customers, many customers in general, they don't want to disturb their transaction systems. So they want to keep the existing mission critical applications running on their OLTP systems, right? Because typically people don't want to mess with that. But when they want to run analytics or when they want to run machine learning, they move the data from their transaction system to the object store. And once they do that, then they can process this data with HeatWave. And when they move this data, they can do it with a variety of mechanisms. Sure, you can do it one-off like an export, but very often people would use things like Golden Gate service so that the data is continuously replicated from their transaction stores to the object store on which they can run machine learning, analytics, and other things. The other thing which may be a surprise to many of you is that HeatWave is the most scalable database in the world, the most. A single instance of HeatWave can span 512 nodes. And the reason we did that is because the target really is data in the object store, which can be petabytes of data. So HeatWave provides all of this functionality, right, with a single endpoint, which is MySQL. It provides a very scalable system. It provides a mechanism by which you can process structured, semi-structured, and going forward, unstructured data as well. Now, what are the other cool things about HeatWave? Well, so this is a slide from Gartner, which says that in the cloud, the only metric which matters is price performance. Right? Because the idea is that if you want better performance, you can just keep adding more gear, sure, but it's going to come at a certain price. And if you want functionality, for any database, what functionality they offer. And these days, all the databases are kind of converging where people end up using, most of the applications end up using some basic functionality. So what really matters is price performance, right? This is a slide from Gartner from, just even as recently as 2 weeks back, they presented this thing to us. So what I want to tell you in terms of the present is that if you believe even part of this, what you will be very impressed to know is that HeatWave provides the best price performance in the industry for a variety of cases. So I was talking about transaction processing, analytics, data lake, and machine learning, right? So now let's see how existing MySQL HeatWave is in terms of price performance for these workloads. So when it comes to data warehouse, so I'm talking about data warehouse where the data is stored inside the MySQL database and you're running various capabilities. HeatWave offers the best price performance in the industry. Right? Over here, I'm showing a specific workload, which is TPCH 10 terabytes. You can change the workload. You can run TPCDS. You can run it on a 30 terabytes, 1 terabyte, doesn't matter. The numbers may vary a little bit, but the fact that HeatWave is the best database in the industry from a price performance standpoint for warehouse is going to be unaltered, right? So as it is, and this has been the case for the last 3 years, HeatWave provides the best price and the best performance in the industry for data warehouse. That's one. Then the second thing is lakehouse. Lakehouse is when you have data in different formats, CSV, Parquet, Avro, in the object store, and you want to process this data. And when we are processing this data, please note, we are not copying this data into the database at all. Data in the object store always stays in the object store, right? So now I'm showing this number. It's for TPCDS, 100 terabytes with concurrency. HeatWave provides the best price performance in the industry. So what is interesting is these other databases I'm talking about, whether it's Snowflake, Redshift, Databricks, BigQuery, they only do one thing. And that one thing may be analytics or lakehouse. They don't do machine learning. They don't do transaction processing. They don't have Autopilot. So here you have one system, one database service, which is doing multiple things, yet it is better and faster than these specialized databases. Right? So the second use case for lakehouse, HeatWave provides the best performance and the best price performance in the industry compared to any of these specialized services, even when the concurrency is high. And then coming to the third category about machine learning. HeatWave offers in-database machine learning. HeatWave offers fully automated machine learning. HeatWave offers explanations for all the models which have been built. In addition to that, HeatWave offers 25 times faster training than Redshift. Now the reason we only have Redshift and not other things is because other vendors don't support in-database machine learning. Even Redshift does not support in-database machine learning. They do it via SageMaker, but we had to compare with at least someone, and that's what we did. Right? So in-database, fully automated, with explanations, 25 times faster, and in terms of the cost, there is no additional cost for machine learning. The only reason I'm putting 1% is because 0% would look silly. And this is a scenario where if a customer provisions HeatWave only to run machine learning, then it is 1% of the cost of Redshift. Otherwise, there is no additional cost. Right? So best performance, best price performance for data warehouse, for lakehouse, as well as for machine learning. That's what we currently have. So what is going on if this is really truly so good? What's happening? Well, a lot of products, right? They have a lot of customers. The thing I want to highlight about this list is that we have many customers of MySQL HeatWave who are migrating to OCI from other clouds because of HeatWave. Now that is very uncommon for any cloud provider. If you take any cloud provider, whether it's Amazon, Google, Microsoft, even OCI, customers first decide which cloud they want to come to, and then they decide, okay, which capabilities or services to offer. And we also have many customers who are OCI customers and they're using HeatWave. But what is interesting is many of our customers come to OCI because of the value proposition, the compelling value proposition of HeatWave. So to give an example, Estuda.com, they were running BigQuery on GCP. The only reason they came to OCI is because they did some POC with HeatWave and they're like, whoa, this is so much better and so much faster and so much less expensive. AI Call. The only reason they came to OCI is because of our machine learning capabilities, right? They wanted to do some fraud detection to figure out, how likelihood is it that their customers are going to default on the loan. That's the only reason they came to OCI, right? So we have a very good traction with customers. Eat easy. These guys were happily running on Amazon with Aurora and Redshift. The only reason they came to OCI is because of HeatWave, and the only reason they came to HeatWave is because of machine learning. And now they're working with us for generative AI, right? So this is the impact customers have, right? Or the product has when you offer the best performance in the industry, the best price in the industry, and the most innovative product in the industry. Okay, so that's what we already have. So what are we going to do next? So this is my point of view, and my point of view is What we're going to do next, over the next 12 to 18 months, is to bring more AI to your data. We already bring a whole bunch of AI to the data, which we have a little bit talked about, but we're going to do more of this, right? So the theme I feel for the next 12 months we're going to do in our product and service, MySQL and HeatWave, is to bring AI to your data. Now, what does that exactly mean? So if you look at it, we've been offering transaction processing, analytics, machine learning, and lakehouse. And with each of these, right, the size of the data increases, the complexity of the application increases, but at the same time, the business intelligence customers get increases. With generative AI and vector store, we are talking about yet another order of magnitude more data, even more increase in the amount of computation complexity, but the value the customers are going to get, what I'm calling business intelligence, is going to be even higher. The other thing which is very interesting and new about generative AI is that the generational capabilities of it, meaning that it is not just returning a subset of the data, it can actually generate, it can actually summarize things for you. So this is why many people feel that this technology is going to be transformational. What people at times miss is that for most of the valuable data in the world, not in terms of volume, the valuable data in the world is stored in enterprises. So being able to provide these generative AI capabilities on enterprise data, that's where there is value, and that's where for us there is business and hopefully more customers. So by offering this, we are going to get into the generational capabilities, we're going to get into the unstructured capabilities with the combination of vector store and generative AI all running inside HeatWave. So we get to, so starting with some specific things over here, right? So the first thing is, by having this capability, we will provide the ability to query unstructured content. In our first version, which we're going to offer very soon, we're going to start off with unstructured text data, but we're going to elaborate or expand to other kinds of text, other kinds of unstructured data as well. The second thing is, we want to bring the power of LLMs to your enterprise content, right? So sure, LLMs are used or trained on public content, and a lot of people do that, a lot of interesting use cases, but this is about bringing the power of LLMs to enterprise content. And one of the very novel ways by which we are doing that is to run LLMs inside HeatWave. So we were one of the first vendors to run machine learning inside HeatWave. So I was talking to some colleagues and they're like, really, are you sure you want to do this? Yes, we really want to do this, because this is going to be much more secure, it's going to be much lower cost, and most importantly, it's going to be much more available. Finding GPUs in any cloud is not easy. Right? There's a lot of demand for it. And it's going to be very expensive to run these generative AI models outside. But if you can run it on this cluster which already has so much of compute, that I think is going to be very interesting and very novel. The other way to look at this is, right, the boxes shown in the red is something we already do. What I'm showing in turquoise over here are things which we are now adding, right? So by adding vector store, we can process unstructured data. By having vector processing, we can actually do now semantic search, right? Or the approximate search. And by the way, each of these, we are talking about the best possible performance. The best possible performance can be what? Memory processing, memory rate. We do vector processing in HeatWave at memory bandwidth, and it scales out with the number of nodes, right? So at times, people say, hey, you're already so fast, can you go any faster? Well, we can only go as fast as any machine can, and the maximum or the best you can do is memory bandwidth. That's what we currently are with our vector processing. And then in terms of the application interface, you can interact with SQL, JavaScript, Python already, and now we're extending that to natural language. I say natural language, most of these LLMs are currently in English, but it won't be too long when other languages are supported. And then finally, I at least believe in terms of ease of use, it's very important for us to have a nice or intuitive UI. And this UI is not only going to let customers query, say in English or natural language, but it will also provide a navigator. And by that, what I mean is that if we want to ask a question, you can say, hey, I want to ask this question in the context of this subfolder. Right? So that's one of the advantages a navigation or a UI gives you. Now, this is another slide I've stolen from Gartner. And what this shows is across data warehouse, lakehouse, and data lakes, what is the level of optimization and what is the level of skills required. Right? Now, guess what? Without generative AI, okay, you need certain amount of skills if you want to do data lake, because that's where more and more data is, and you get certain level of optimization. With generative AI, here's an interesting thing. Your optimization may not improve so much. This is per Gartner. But what is going to be significantly improved is the skill set, right? And at the end of the day, the most valuable thing out there is people's time. So what this shows as a concept, right? And this is very, very similar to what we have already seen with Autopilot work we have done with database, right? If you can significantly reduce the time it takes to tune a database, tune a service, right? Not only are you providing better performance and lower cost, but what you're really, really helping is saving developer time, saving DBA time. Right? And that's what will become even more important as we talk about data lakes, as we talk about generative AI. And then in terms of the class of applications which will be enabled, right? So we support analytics, we support transactional processing, we support machine learning, but combining generative AI and vector store, this is going to enable a whole new class of applications. We're just scratching the surface. So for those of you who maybe in the previous talk, where I was talking about generative AI use cases, this is just scratching the surface, because in V1, we're just talking about handling unstructured text data. Just imagine when you can process images, when you can process audio files, when you can process other kinds of data as well. Okay, so let's talk about some use cases over here. So this is actually one of the largest banks in the world. They've been doing a POC where they have their transactional data in some database, and they want to use HeatWave for running analytics and machine learning. So even with the value proposition we provide, like say a year back, which is analytics and machine learning, they are moving this data from this transactional database to the object store and running HeatWave. Then they said, you know what? We want to do some anomaly detection on what they call mule accounts. The basic idea is that people are bringing in money, and they suspect that they may be opening these fraudulent accounts to siphon money, right, or taxation. So they are using anomaly detection to figure out which of these accounts are suspicious, right, or what is anomalous. That's what we currently do. Now this is a prototype which our team member ran on this data. Not only can we flag these anomalous accounts, we can actually give a summary which is super valuable for the operator or for the person who's in charge of the service or the bank to figure out, is it truly something which they want to investigate or not, right? So having anomaly detection itself is super valuable. Otherwise, how are you going to mine all this data? But now being able to describe what that anomaly is can really level up the game. Now, but this doesn't happen automatically. Right? The reason this is happening is because of the investment we are making of integrating AutoML, the machine learning which runs inside the database, with generative AI. Right? So this is kind of the IP, or this is the knowledge base we are building, or this is the value we are providing. Because otherwise, customers could pretty much take the data, take it out of the database, and run it on LLMs, right? Or perhaps, okay, they can use a vector store to run LLMs on their enterprise data. But this kind of integration does two things. It improves the quality of the output, and secondly, it makes the system or the performance of the LLM faster. Because remember, one of the goals we have is to run LLMs inside the database. So these are the kind of techniques we have to build so that you get the value, the quality, the performance of large models running on GPUs, but at a fraction of the cost. The other thing which we are doing, and again, just the theme, remember I'm talking about bringing AI to your data. So what we talked about is generative AI on unstructured data. But now with respect to AutoML, there are a whole bunch of domains, and you saw Wim talk about it. So one of the things we are finding is that AutoML is very useful for a whole bunch of domains, and for each of these cases, right, there are some common themes which these domains have. So what we are kind of working on is providing some functions for each of these domains. Like I gave you an example of financial fraud. Similarly, we have many customers who want to do things in predictive maintenance, or there are customers who want to do something in online retail. So what we're going to do is to provide a mechanism by which we have some sample functions, if you will, which can be used for the most popular verticals which we have seen. Okay, when we say bringing AI to your data, and I'm just giving you again examples of things which we are doing and which we are going to augment more. There is one strategy to say that, hey, you know what? You have your unstructured data, you transform it, you create the embeddings, and we can do the vector processing. Well, that itself is interesting, because now instead of just doing processing on structured data, the databases can now do processing on, say, unstructured data. But you're leaving a lot of onus on the users. Just figure out man, there's this guy, he hardly knows much about databases and such, and now you're saying this unstructured data, figure out which is the right parser to use, which is the right embedding model to use, and oh, by the way, when you want to query this data, make sure that you don't use a different embedding model, right? Chances are the guy is never going to do it, right? What we are doing is we are offering all of this capability inside the database to really empower the customers to leverage AI on this data, right? So we're like, hey, you just park your data anywhere you want, and that anywhere most likely be the object store, because it provides the least expensive, most durable, most shareable way of storing data. And then from there, we will provide you all of this value, and guess what? We will never copy your data into the database because we don't want to bloat your database, because then your cost will be high. So right from document discovery to parsing to embedding generation and then to creating the vector store is all done automatically inside HeatWave. Now, I have mentioned this thing about in database LLMs. I believe that's really going to be the future. GPUs will have a value for certain class of applications, but for the kind of enterprise use cases we see, the last thing customers want is to move data somewhere else, is to pay even more for GPUs, and most important, not know when these GPUs are going to be available or the service is going to be available. So although we are providing that as an option, I do believe that in database LLMs is what most of our customers are going to use. And the big benefit now customers get is that they can run it, obviously, in any public cloud region. They can run it in a dedicated region. They can even run it in a government region, because all of these things are going to be certified, right, to run in any region. The next aspect, right, from a UI perspective is, again, in the spirit of bringing AI everywhere. So in our entire stack, whether it's storage, whether it's query processing, whether it's UI, we're going to expand the presence of AI. So this is, we are taking the VS Code plugin, which we have for MySQL shell, in addition to users being able to query data in lakehouse using SQL, they can also do it in natural language. Okay, so when I started off, I said that, look, we already bring a lot of AI to your data, and we're going to do more of it. So anyone can say that, but here is what I actually mean. We released this service at the end of 2020, and since then we have had a constant stream of innovations which we've been doing to bring in more and more of this machine learning based automation, right? And there are multiple aspects which we have over here, right? It's for data management, it is for query processing, it is for error recovery, it's for provisioning. And many of these things, we're the first in the industry to do it. Like, no one looks at the data in the queries to figure out what is the right size cluster to use, or what are the right number of cores to use, right, for an OLTP system. So we have already been doing that. So we have now 26 features. 7 of these features are going to be coming in the next few months, but we have 19 features which have been around for quite some time, which uses machine learning, which uses the user's information about the workload and the data to make appropriate recommendations or automate this thing. And just to be clear, we never use one instance data for some other instance, right? So your data is your data. Any knowledge which we glean from your data, we are only going to use it to improve your service, right? Not even the service of your tenancy and some other instance, right? Only on your specific instance. So things like, figuring out what is the right cluster size, what is the right core count, what is the right partitioning scheme. So HeatWave, one of the reasons HeatWave is so scalable is that when we load the data, we partition the data, but this partitioning is done based on the query characteristics. So as your query changes, the system makes a recommendation that, look, man, it's time now to change the partitioning key. Not just that, the system also makes a prediction saying if you change the partitioning key, this is so much of an improvement you're going to get. Right? So we have already had these features, and now we are adding 7 more. So now we have in total of 26 features. Now what's next? Well, HeatWave has this engine called, we have a multi-engine optimizer, meaning that MySQL has an optimizer, HeatWave has an optimizer, and now they have been combined in the last release. So it's a multi-engine optimizer. It's a lot of work to have a single optimizer in some ways, but we are trying to get best of both the worlds. The thing which we are now working on is to make it even better. So right now what happens is this multi-engine optimization looks at a query, regardless of whether it's executing on MySQL or in HeatWave. Both these optimizers are involved to kind of come up with the best plan. And there are 2 things which we're going to enhance even further. The first thing is, in HeatWave, we collect a lot of advanced statistics. Like we have sketch-based statistics, we collect min, max. We are going to feed all of that information even for OLTP workloads running on MySQL, right? So we are getting this information from the cloud, feeding it to the node, which is just doing transaction processing. This node may never be running HeatWave query, right? So that's the first thing we're doing. And then the second thing is, we collect whatever statistics we can, the system predicts whatever statistics they can, but now we're going to start introducing machine learning capabilities to predict the cardinality of various operators. And this has far-reaching implications when it comes to the kind of plans an optimizer can generate. So just to give you one, and I don't want to sidetrack too much into this, but people talk a lot about vector indexes. Well, right now, most of these vector indexes work only on a single predicate. If there are multiple predicates, it's tricky for the optimizer, at least in the case of Postgres, it doesn't work if you have multiple predicates. One of the reasons it doesn't work is because it makes some assumption about the selectivity of the second predicate. Now we're going to use machine learning techniques to predict what is going to be the selectivity of this other predicate, which will make the execution plans much better. The second thing is, we're going to be applying a machine learning to all the phases of query processing. So when to offload a query. That's not going to be rule-based. That's not going to be statistics-based only. That's going to be based on a model. And there are two things to keep in mind. Not only does the model make a prediction, the model also gets the feedback, whether it was correct or not, and then over time, keeps improving. This is one of my favorite features which we have in Autopilot, where already for HeatWave, as you run more queries, the system learns from the previous queries. It learns from, say, the cardinality of the various columns or the selectivity of the various predicates which were executed in prior queries. And when you have a new query which only has a subset of those columns which are common, or a subset of those operators, it is able to influence the new queries based on a query which was never run earlier. This is very interesting and very new, which is why with HeatWave, as you run more queries, the system gets faster or the system gets more intelligent. Well, we are working on extending these same capabilities for the transactional processing case, for the OLTP case. The next thing which we are doing is the JSON duality. Right? So JSON is very popular, and there are a lot of companies, including Mongo, which have done really well over there. Relational databases are very popular. They have done really well. Instead of this dichotomy where you need to decide whether to take a database which processes JSON well or like structured data well, we are working on JSON duality. And what that does is that it gives you the abstraction of a document as well as the abstraction of a relation table. So in some sense, best of both the worlds. And again, we're going to expose all of this via our VS Code plugin. I talked a little bit about this in my earlier session as well, where one of the not only is MySQL the most popular open source database in the world, but it's super popular amongst developers. And what do developers do for the most part, or at least in a large case, is that they extract the data from the MySQL database into some client and do a lot of that processing. So for one, we're introducing JavaScript, so they don't need to do that, right? Complexity, they can push that complexity into the server. The second thing is we are working on this HeatWave REST service, where now transparently, if you have a mobile device, if you have some other like REST endpoint, you can just interact with the database without any middle tier, right? So that's what the REST service is. And then finally, I just want to remind you that we are the only cloud service or only service from Oracle which runs natively, not just in OCI, but in AWS. So the data plane, control plane, console, they all run natively inside AWS. And the reason is because there's a lot of data, a lot of services in AWS whom we believe can benefit from HeatWave, which is why we see, like the customer I was saying who went production with JavaScript, they're actually running HeatWave on AWS in production. But we're going to continue to improve that, for instance, like lakehouse, autopilot indexing, and some of these capabilities. So with this, I'm happy to take any questions, comments, any feedback. Any questions? Yep. Oh, okay. So there are two parts to your question. If you have your data in S3, you have two choices. One choice is you can run HeatWave in AWS, so there is no data egress, and you can get all of these capabilities inside AWS. That's something which already works. The second thing is, if you want to run in OCI, yes, you can, but the data will need to egress from S3 to OCI. Right? The part which we don't provide is, we don't provide automatic connectors directly currently to suck data from S3, right? Because again, there's an egress charge. We have to figure out who is going to pay the egress fee. Amazon charges, someone has to pay, right? That's why it's a little tricky there. But you can run it absolutely on S3, or on data on S3 right now.
Does the multi-engine optimizer generate plans that come from potentially both, or one or the other?
Right. So the way we are designing is, okay, so currently it comes from both, right? But if it is going to run on, okay, so there's a logical plan, and then there's a physical plan, right? So the logical plan is influenced by both, but the physical plan, once we decide if we're going to run in MySQL, it's finalized by MySQL engine, and for HeatWave on the HeatWave engine. Now what we are working on is, we are collecting statistics based on, say, queries which were run on the HeatWave side, which were not running on OLTP side, but we have a much more accurate characteristics of this data because it's analytics and it's machine learning, and we feed those statistics to the MySQL, this combined optimizer. That's additional part we are working on. And the second thing is, we will use HeatWave to do machine learning, because machine learning only works in HeatWave. So we will use HeatWave to make the machine learning prediction about the cardinality. Once we have that number, we will feed it to the MySQL optimizer. Any other questions? Yeah. Yeah, look, the Azure story is still being worked on. We had this interconnect. So in concept, yes, but there are some kinks right now. So Azure integration for HeatWave still has some work remaining. We are working on it, something now we have even better idea, because, you know, right, Exadata, for instance, is offered inside Azure. So now we are thinking, hey, will that be a better thing for us to do? So we are kind of like trying to like redesign this Azure aspect. Right. You can try in many cases, right? But if there are, for instance, take the case of spatial operators, that's currently not supported in HeatWave, right? So there are some examples where the query just cannot run, and then it cannot run. But yes, you can influence it to some extent. But we want to have a hint-free system, so which is why the optimizer tries to do that, but you can try to influence it more. Any other questions? All right. Thank you for your time.